Alright, so we're going to go ahead and take a look at the power rule, which is kind of the most basic rule used to find the derivative of various functions. And, you know, the previous couple of videos discussed some things about the definition of the derivative. And, you know, if you see, you can kind of see certain patterns when you use that definition of the derivative. And that's basically, you know, kind of where we're going to get this power rule from right here. We're not going to prove the power rule. But the power rule, how it looks is this. So if you have a function in the form x to the a, where a is some constant, some number, okay, it could be any number, the derivative of that, say f prime of x, okay, is equal to, what you do is you take the exponent, bring it down in front, so a, x to the, and you subtract 1 from the exponent, a minus 1, like that. So let's just look at a couple examples here. So say you have like h of x was equal to x cubed. Well, if you were trying to find the derivative of that, h prime of x, to apply the power rule, you just bring the 3 down in front, subtract 1 from the exponent, and become 3x squared. And again, if you use the definition of the derivative, the limit process for the derivative to find this derivative, you get the same exact thing. Just obviously you can see here, a lot less time. Okay, kind of a nice shortcut here. Say we had something like this. G of x is equal to 5x squared, for instance. Okay, so if you have a constant in front right there, how we're going to deal with this, you're going to bring the 2 down in front and multiply it by that constant. So the derivative here would be 10x, and then you subtract 1 from the exponent, so it would become x to the 1, but you can just write 10x. Okay? So that's kind of some very, very basic ones right there. Let's go ahead and take a peek at a couple other ones here. Say you had, like f of x was equal to, let's just say a constant, like 15, for instance. Okay? So in this case, there's no x there. So a couple different ways you could think about this. One, you could think about it logically and think, okay, well, 15 is just a horizontal line. That is it. Okay? And the derivative, as we know now, is a rule for the slope of the function. So it just tells what the slope is of the function. So the function 15 is a horizontal line that has a slope of 0 all the time. So the derivative of 15 is just going to be 0. Okay? You could, if you want to, still apply this power rule to it, which, you know, you should just think of the derivative of a constant as 0. But I just want to show how the power rule does apply to this, because you could rewrite this as like x to the 0. 15 times x to the 0, since x to the 0 is just 1, so that would be the same thing. And if you were to apply the power rule, you'd bring the 0 down in front to multiply by the 15, and then you'd subtract 1 from the exponent and get, you know, x to the negative 1. But multiplying 0 times 15 makes it just 0. So the derivative of 15 is just equal to 0. And the derivative of any constant is equal to 0. Okay? So it could be, you know, your function could be 10, could be pi, it could be e, it could be 100. All of those would have a derivative of 0. There are certain times where it's good to rewrite your function before you take the derivative. So let's say we have y is equal to 1 over x cubed, for instance. Okay? That, as it is not set up to use the power rule, because in order for it to be the power rule, it has to be something where it's x to the a power. And this is, you know, 1 over x to the a power. So this is, you know, close, but not quite. So what we can do is, before we take the derivative, I'm going to rewrite this as x to the negative 3. Okay? So now it's, you know, perfect such that it's set up for the power rule. And what I can do now to take the derivative, and I'll just do a different notation. The derivative of y can be written as y prime or dy over dx. There's several different ways you can write the derivative notation. And what you would do here is you just take the negative 3 down in front and write it as then x to the negative 4, because I'm subtracting 1 from the exponent. So negative 3 minus 1 is negative 4. So that's the derivative there in that case. The same thing you could you know, apply with like a square root, for instance. If I had like square root of x, okay? Before I took the derivative of that, I could rewrite this as x to the 1/2, okay? And so now it's set up in the power rule, so I can just take the derivative here nice and quickly. And that's going to be, bring the 1/2 down in front of the x, 1/2 x to the negative 1/2. Okay, there you go. Pretty exciting stuff there. And you can also take the deriv if you have a function that's a polynomial with multiple terms, or not necessarily even a polynomial. So let me just say, for example, if you had something like this, say 10 minus 3 over x squared plus the cubed root of x, for instance. So when you have a function with multiple terms, you're just going to take the derivative of each term separately. So before I go about taking this derivative, let me just rewrite it. So this is not taking the derivative at all, I'm just rewriting it. I'm going to bring the x up to the top to write it as x to the negative 2, and then plus the cubed root, I'm sorry, I'm going to change, instead of writing the cubed root, I'll write x to the 1/3. Okay? And then the derivative of this will become, so the derivative of 10 is just 0, since 10 is a constant. The derivative of this, I'll bring the negative 2 down in front, times the negative 3 will make it 6x to the negative 3. And then here bring the 1/3 down in front to make it plus 1/3 x to the, and let's see, I'll subtract 1 from the exponent to make it negative 2/3. Okay? And, I can leave it like that. If you want to rewrite it with positive exponents, you could put the exponents in the bottom. That would be fine, but that's, this is the derivative, so I can leave it like that. One quick thing I want to mention real quick, it's just more of an algebra issue, but just something I see as a common mistake, that I noticed as I was just going through problems like this. If you had something like this, 1 over like 3x to the 4th, for instance. Something I see that people do on this when they rewrite it is to bring the 3 and the 4 up together. So, and write it as, 3x to the negative 4th. So write it like this, and this is wrong what I'm going to write right here. I'll erase it in just a second, but this is what I see people writing as 3x to the negative 4th. This is not correct, okay? Because in this case, you have brought the 3 up to the top without adjusting its exponent at all, okay? So, you would have to change that to like a 3, a negative 1, for instance. Okay, so that right there, is not appropriate. That would not work. The way you should write this is 1 over 3 times x to the negative 4. Okay? So you're only bringing the x up and changing its exponent. Leave that as 1/3. And then when you take the derivative, it would become negative 4 over 3 x to the negative 5.